Hello dear students. Today we are going to learn on this unit states of matter and properties of matter. I, Dr. Smita Pimple, Professor, Department of Pharmaceutics, working at Peace Society's Modern College of Pharmacy, Pune. Before we begin with the topic, I will let you know the learning objectives of this unit. You will be able to understand the nature of intra and intermolecular forces that are involved in stabilizing molecular and physical structures. You will understand the differences in these forces and their relevance to different types of molecules. You will appreciate the difference in the strength of intermolecular forces that are responsible for the stability of structures in different states of matter. You will understand properties of different states of matter, describe the pharmaceutical relevance of different states of matter, describe the solid state crystallinity, solvates, polymorphism, describe and discuss key techniques utilized to characterize solids. These objectives were listed for Unit 1 and the contents of Unit 1 will be covered in series of videos. So in the present session, we are going to learn about binding forces between molecular gaseous state, deviation from gas theory, compressibility factor, van der Waals equation for real gases and correction for pressure and volume, critical constants, liquefaction of gases, in that Linde's process, Claudius process, and application of liquefaction to aerosols. Further, we will be studying different states of matter, transitions, latent heats, vapor pressure, sublimation, critical points, eutectic mixtures, then gaseous state, relative humidity, liquid complexes, liquid crystals, glassy states, then coming to solids, in that classification, crystalline and amorphous, methods of crystal analysis, X-ray diffraction with Bragg's equation, polymorphism, various applications of polymorphism in pharmacy, and detection techniques. So let's start with states of matter. Since primary schooling, we are studying that there are basically three states of matter, and that is gaseous, liquid, and solid. Now at this stage, many of the students will be knowing that there is fourth state of matter. It is also identified, which is referred as plasma. So today we are going to discuss about these four states of matter, solids. Now in the figure you can see a sculpture made from ice, which is in the solid state. Then liquid state of matter. For the example purpose, you can see the picture of a drop of water. And gases, which is nothing but air around the cloud, and plasma, where electrical arcing from a Tesla coil is shown, for example. Now these are different states of matter, and behind existence of matter in different states there are certain reasons, and the reason lies in the presence of intermolecular forces of attraction. But before discussing those intermolecular forces of attraction, we will see properties of these different states of matter. So solid state, it maintains a fixed volume and shape with component particles. They may be atoms, molecules, or ions, and close together, and they are fixed into place. So they are not free to move, they can only vibrate about certain fixed position. Second, liquid state, it maintains fixed volume, but it has variable shape. It adapts to fit its container. That means it is not having any inherent shape, but it will mold itself according to the shape of container. Particles are still close together and they can move freely. Next is gaseous state. It has both variable volume as well as shape, and it adapting both to fit the container and the particles are neither close together nor fixed in place. Plasma state, this is the fourth state identified. It has variable volume and shape, but it has neutral atoms. It contains significant number of ions too and electrons, both of which can move around freely. Plasma is the most common form of visible matter in the universe. Students, plasma is just when you supply certain definite high energy and temperature to gaseous state, which is unionized, it gets converted into ionized form. This ionized form means nothing but the molecules, gaseous molecules or atoms, these are stripped of certain electrons and converted into ions. Let's see some characteristics of this fourth state of matter, plasma. The plasma, it is described by a chemist, Irving Langmuir, in 1920s. It consists of ions or atoms which have some of their orbital electrons removed. Plasma can be artificially generated by heating a neutral gas or subjecting it to a strong electromagnetic field to the point where an ionized gaseous substance becomes increasingly electrically conductive. So based on the temperature and density of environment that contains plasma, sometimes partially ionized or fully ionized form of plasma can be produced. The examples of this plasma state, you can see neon signs or lightning where you will get partially ionized plasmas. So this is just nothing but the gaseous state, but you are not having molecules. Instead, you are having ions or ionized gas as plasma. Now students, I told you that behind existence of different states of matter, the reason is intermolecular forces of attraction. Now, how these intermolecular forces of attraction develops? Now, you all know the matter, every matter has basic building unit is molecule, and molecules are made up of atoms. In atoms, you know that they are composed of electrons, neutrons and protons. So neutrons and protons are in the nucleus, and surrounding this the electrons are revolving in orbitals. So the molecules has these atoms where some positive and negative charges are combined. Now, depending on distance between these molecules, okay, the charges, positive and negative, they had some interactions. Now, these interactions and their energies we can study in the diagram shown here. To understand this diagram properly, consider that two molecules are present and the distance between them is quite large, so that no attraction or no repulsion is present at a certain distance. So when the distance is very large between them, neither attraction nor repulsion is present between them. But as they come closer, then attraction and repulsion forces starts acting on them. So till they reaches at equilibrium distance d, then attractive force equals to the repulsive force. If two atoms are brought closer, the repulsive force will dominate and produce a net repulsive force between the atoms. Means if the distance between them, it goes even less than this equilibrium distance d, then repulsion will prevail. But if the distance is greater than d, then net attractive force will prevail. So at a certain distance, you can see here, and it is reported that the distance is approximately 3 to 4 angstrom units. That is the d distance where you have equilibrium. If distance is more than this 3 to 4 angstrom, then attraction will be more, and if it is less than 3 to 4 angstroms, then repulsion will prevail. Now, binding forces between molecules, they can be classified in different ways. First classification, it is intramolecular forces and intermolecular forces. So intramolecular, as the name suggests, it is bonding within molecules. That means attraction that occurs between atoms in the molecule. Intermolecular is bonding between molecules. So just to represent intramolecular, it is, here you can see water molecule where hydrogens, two hydrogen atoms are bonding with one oxygen atom. So this is intramolecular. And here you can see two water molecules. They are interacting with each other, but that is intermolecular bonding. The forces can also be classified as adhesive forces and cohesive forces. So adhesive are attraction forces between different molecules. That means if the attraction is between, for example, NaCl and water, it will be referred as adhesive force. And cohesive force means attraction between same molecules. That means if water molecules attraction is there, it will be referred as cohesive forces. Now we will study in detail intramolecular bonding or intramolecular forces. These are classified as ionic, covalent and metallic. Here you can see in this table the basic model for all these three types of bonds. Then basis of attraction, energy, that is nothing but bond energy, and some examples. So just the ionic bonds are developed between the cations and anions. You can see here one cation is surrounded by an anion and the forces are developed, they are very strong. This can be, you can get an idea about the strength of ionic bond from these bond energies, 400 to 4000 kilojoules per mole. Bond energy is a representation of the strength of the bond. If it is high, then bond is very strong. So ionic bonds are considered as strongest. The example is NaCl. Bond energy is nothing but the energy which is required to break the bond. So if it is more, that means the strength of the bond is higher. Covalent bond, it is formed when the nuclei shares a lone pair of electron. It is also a one of the strong bond where, but it is less strong as compared to the ionic bond. Its bond energy lies between 150 to 1100 kilojoule per moles. Example is hydrogen gas H2. Metallic bonds, these are cations and delocalized electrons and the bond energies are 75 to 1000 and example is iron. So these are intramolecular bondings and they are comparatively very strong bonds which you can see from their bond energy values. Now next we are coming to intermolecular forces of attraction. These are very much weaker forces as compared to intramolecular forces of attraction, but these forces are responsible for existence of matter in different states. So these we are going to discuss in detail in the next video, but for time being we will revise what we learned today, that is basic four states of matter: solid, liquid, gas and plasma. Their properties we have studied. Then we studied how the attraction and repulsion forces changes with respect to distance between two approaching molecules or atoms. We have studied classification for bonding forces between molecules, that is intermolecular, intramolecular, adhesive forces, cohesive forces. Intramolecular we have three types, that is ionic, covalent and metallic, and intermolecular we are going to study in the next video. Thank you students for listening patiently. Bye for now.